Hey everybody. In a previous video, we saw how a particular set of weights and biases coupled with a neuron allows that neuron to mimic a logical AND statement. In this video, we'll just do another example, but this time we'll mimic the logical OR function. So the OR works in the following way. Something is going to be true. Something is going to be equal to 1 if either x1 is true, or x2 is true, x2 is true, or both of those statements are true. So here, for example, in this last case, x1 is true and x2 is true. It only takes one or the other. They both happen to be true, and so our output is true. In these two cases, we have x1 is true and x2 isn't, but that's okay. x1 is true and that's all it takes. Y is going to be true. In this case here, x1 wasn't true, but x2 was. We only need one or the other to be true, or both, and that gives us true. The only case where we're not going to get a true is when neither x1 nor x2 are true. In other words, when x1 and x2 are both false, then y is false. But in all other cases where at least one or the other or both are true, we're going to get a true statement. That's what we mean by a logical OR function. Given these inputs, any one of these sets of inputs, we should be able to get the corresponding outputs. So can we mimic this with a single simple neuron? Well, let's remind ourselves, what is a neuron? A neuron is just two little steps. We have an aggregation, the linear part. We have W1x1 plus W2x2 plus the bias, and then a step function. If z is positive, then we're going to guess a 1. If z is negative, then our output, our guess, is going to be a 0. Right? And we're hoping that with the right set of weights and biases, we'll be able to mimic this entire truth table. So let's try out the following for size. Let's try W1 is equal to 1, W2 is equal to 1, and our bias is equal to -0.5. That should be enough to get us to mimic this logical OR truth table. So let's plug in some values and simplify our function here. So the function, again, our neuron reduces down to 1 times x1 plus 1 times x2 plus our bias, which is -0.5. So this is now our neuron when it's appropriately parameterized. So can this neuron, this guy right here in the box, does this mimic this truth table here? We have 4 cases to consider, and we'll see that it should be able to mimic all of them. We'll do A first. All right, so we're going to plug in zeros for x1 and x2 and see if we also get a 0 for our output. All right, so we're going to plug in zeros for x1 and x2 into our neuron. Well, that's just -0.5, and we know that when z is negative, we get an output of 0. And that's exactly what we needed. So we're good there. But will we get 1s if either x1 or x2 are 1, or maybe both? Let's see. Let's check these other cases. So let's try case B. So case B has a 0 for x1 and a 1 for x2. So we're going to plug in a 0 here and a 1 there. All right, so that's 0 plus 1 minus 0.5. So that's 1 minus 0.5, which is just 0.5. That's a positive number, and so y hat is 1, and that's good because that's what we wanted. Case C is going to work exactly the same way. We're going to plug in a 1 for x1, a 0 for x2, subtract off the bias there. We have 1 minus a half. That's also a half. And so we get a 1 here. This positive number, and so we're in this case here, and y hat is a 1, and that's what we wanted. So we're good there. And finally, with case D, let's try that out. There's our neuron. We're going to plug in 1s for x1 and x2. That's 2 minus a half, which is 1.5. That's a positive number. Since z is positive, our y hat is true, is a 1. And so we get all of the appropriate values for our output. All right, so if we had a neuron and this set of weights and bias, that mimics a logical OR. All right, that's it. Thanks.